Once again, you're welcome to Waidsum Academy. Today we're looking at mensuration, part 5. And part of mensuration we're looking at today is cone. Okay, so we know a cone, it's it looks like triangular, even though the base is a circle. The base is a circular shape. Okay, you look at the base of a cone, and then this is like a slant height, and this is the vertical height. You can draw the height from the center to have a vertical height, or is as shown here. This is the height of the cone, and this is the slant height, L or S, depending on some text. Okay, so we're starting with the first one is the volume of the cone. So we say the volume of a cone is more or less like a pyramid, looks like. Okay, looks like a pyramid. Remember when we did pyramid, we just needed a base area, and then we take all the lines to meet at an apex at a particular point. So that was how a pyramid looked like. So a cone is not like a pyramid with a circular base. A cone is just like a pyramid with a circular base, right? You know, the other pyramid we studied, we have the rectangular base pyramid, we have the square base pyramid, we have the triangular pyramid base pyramid, we have the pentagonal base pyramid, we have the hexagonal base pyramid. So we looked at the different pyramid. So a cone is actually like a pyramid with a circular base. A cone is a pyramid with a circular base. So we say a cone is a pyramid with a circular base. Now the formula for its volume is therefore same as for any other pyramid. So the formula for the volume of a cone is same as the volume of pyramid that we've looked at. Remember we said the volume of pyramid is 1/3 times the base area. In this case, this is the area. In this case, this is the area times the base area of a circle times height, this height. Okay, so but in this case, the base is a circle, so we put the area of a circle as the area of our base, which is pi r squared. So we say 1/3 pi r squared multiplied by h. So that's why the formula for calculating the volume of a cone is simply 1/3 pi r squared. 1/3, the volume is 1/3 multiplied by pi r squared multiplied by the height. Pi r squared is the area of the base, because the base is a circle. The base is a circle. Then multiplied by the height. So this is the formula for calculating the volume of a cone. For calculating the volume of a cone, since a cone is simply a pyramid with a circular base, so it's same formula for calculating pyramid. We can simply say we are using the same formula as in the case of a pyramid. We are using the same formula as in the case of a pyramid. The only difference is that our area is constant. You know, in a pyramid, the base area could be a rectangle, the base area could be a pentagon, any quadrilateral, a pentagon. It could even be a trapezium. Okay, the base area could be hexagon. So it's not fixed. The base area is not fixed. But in the case of a cone, the base area is fixed to be pi r squared. Then we now multiply by h. 1/3 times the base area times height. Now let's take a look at the first example. The first example says calculate the volume of the cone. So you can see the radius, r is 4 centimeters, and the height is 8 centimeters. So volume is simply to key in the value into the formula. The volume of a cone is simply saying the volume is simply calculated by keying the value into the formula 1/3 times pi r squared. We put the value of pi, which is 3.14. Okay, 3.14. 3.14 times the radius, which is 4 square. So we say times 4 square, which is 16. 4 square is 16. Then times the height which is 8 centimeters, times the height which is 8 centimeters. Okay? So now let's calculate. You multiply the numerator first, then you divide the answer by 3. 1 times 3.14 times 16 times 8. Then we divide the answer by. Multiply the numerator first. 1 times. Okay, times 16 times 8. So what do we get? The volume is 134, right? 0.1. So volume will be 134.1 centimeters square, or 0.05 centimeter cube. Centimeter cube, because we're looking for volume. So that's the first scenario. Approximately to 3 significant figure, you just write 134. Okay, to 3 significant figure, 134 centimeter cube. And let's say the second question. It says the sector below is able to form a cone. This is a sector, okay, with a major arc. This arc is a major arc. Okay, the angle is 280 degrees. If you want the minor one, we don't need it. If you want the minor one, you say 360 minus 280, you get what it is there. I think it will be around 80 degrees. Okay, so the sector below is able to form a cone as shown. Find the volume of the cone. Okay, he said we should find the volume of the cone. Okay, so the first thing we do, you can see in this cone, we are not given the radius and we are not given the height, only the slant height. So the h is unknown, right? We don't even know this h. We are not given the radius, neither are we given the slant height. So we don't know h, 8 centimeters. So we have to find this arrow, the radius, and h first. 8 centimeter and arrow centimeter first. We have to find it. It is after we've obtained them that we can begin to find the volume of the cone. So we have a sector that has been given to us that was used to make a cone. It says calculate the first thing we're going to do, we're going to find the circumference of the cone. Okay? We're going to calculate the base circumference of the cone. The base circumference of the cone is equal to the length of the sector. It's equal to the length, that's the arc length. See this arc length? This arc length. This arc length of the sector will be equal to the base circumference of the cone. It is this one, this arc length, so that will form the base circular part of the cone. Is what they used to make. This length is what was used to make this circle. So let's write from here this arc. We can find the radius first. So we can say arc length from the sector. You can say from the sector arc length will be equal to, let's write the formula for the arc length of the sector. Okay, arc length is equal to theta or phi, whatever you want to use as the angle, theta over 360. Remember, we've done this in part 4, no part 3. Okay, theta over 360 times 2 pi arrow times 2 pi arrow. No pi arrow square. We are not doing the sector, area of the sector. We are doing the length. times 2 pi r, right? So that's what we're going to use. So from here, we have the sector. In the sector, the slant height of the cone will be the area in this case, will be the radius in this case, this one, this 12. This 12 centimeter will be our radius, okay, of the arc, will be equal to this slant length is equal to the radius, okay, equal to r. So here, r equal to 12. R equal to 12 from the cone. R equal to 12. This was given in the cone. This slant length is equal to the radius. Slant length from the cone equal to the radius of the sector. Equal to the radius of the sector. So we substitute our value and let's find the arc length. The arc length will be the circumference of this. You know, once we calculate the circumference, then we'll be able to calculate the radius of this cone. So let's calculate the circumference. Circumference is our arc length. So let's find arc length. So this will be equal to theta, which is 280 degree. 280 degree over 360. 280 degree over 360. Usually we have this type of question in the exam. Usually we have this type of question. They draw one shape. They say the shape was used to make the other shape. So calculate this, calculate that. So we need to pay attention to this type of question. These are standard IGCSE questions. Times 2 times pi. Pi is 3.14 or 22 over 7. 3.14 times, like we said, our radius of this one is this slant length. So times 12. So let's key in this value and tell ourselves what we get here. So at the end of the day, what do we get? Okay? So at the end of the day, what do we get? 360, you can actually start we can actually start to cancel this 0, can actually cancel this 0. So we get 58 point what? 0.65. So we get 58.665. You know, arc length is centimeter. So we put centimeter. So this is the length of our arc. And remember, this will be, the base circumference is 58.65 centimeter. Okay? So that's the first one. The next thing for us to do is to calculate the base radius of the cone. Like I said before, I said once you get this arc length is equivalent to the base of the circle of the cone, the base circular part of the cone. So this is the base circular part. So we can say this is equal to the base circular part of the cone. Or we just say base of cone, equal to the base of the cone. The base of the cone. So once that is established, that the arc length is same as the base of the cone, then we will be able to realize the circumference. You know, the base of the cone is a circle, so circumference C is equal to 2 pi r. Circumference C is equal to 2 pi r, right? So from here we can find the radius of the cone. Here we can find the radius of the cone, right? The circumference is equal to 2 pi r. So we make r the subject. If you make r the subject here, we'll get what? We'll get r will be equal to the circumference, which is 58.65. Circumference divided by 2 pi, right? Divided by 2 pi. I am only making it the subject. Okay, so this is equal to 56 sorry, 58.65 divided by 2 pi. 2 pi is 2 times 3.14, which is 6.28, right? So you divide this by this. So you divide this by this, you will get 9.33. You get 9.33. 9.33 or 9.33 something, you get something of that nature. 9.33 or 9.34. If you approximate to 2 decimal place, it will be 9.34 centimeter. Okay, that's the radius. So we calculated the radius. Remember the question is saying we should calculate what? It said the sector below is able to form a cone as shown. Find the volume of the cone. Okay, before we can find the volume, we should find the radius. Cannot find the volume of the cone without finding the radius. So now we also have to find the height. So to find the height, we're going to use Pythagoras theorem. You know why? We're going to bring out this as a right angle triangle. See, this is the height h. This is the radius. This is the slant height s, or so this is the radius r. This is the h, the one we're looking for now. Here is angle 90, and here is the slant height. We call it L. Okay, the slant height, which is 12. This slant height is 12. This one, either this way or this way, is 12. So here is 12 centimeter. Here is 12 centimeter. And here, we already found our radius to be what? 9.34, right? Radius we got just now to be 9.34 or 9.33. So we got our radius to be 9.34. So we need to find height using Pythagoras theorem. So here, because the right angle triangle, we're going to use what we call Pythagoras theorem. Pythagoras theorem. So since it's a right angle triangle, we have to use Pythagoras theorem to find the height. So once we get the height, we have to use Pythagoras theorem to find the height. Okay? We use Pythagoras theorem to find the height. So, which is h square, L square plus R square. Remember Pythagoras theorem, right? Equal to, sorry, I say L square plus R square. This is h square. This one, the two short sides square, the square of them, add them, equal to L square, the longest side square, equal to L square, okay? So once you have this, we make h square the subject. So h square is equal to L square is equal to L square minus R square. So we just put the value. L square is 12, so we say 12 square. 12 square minus R is 9.34 square. 9.34 square. That will give us our h square, and then we find the square root. So what do we get? What do we get? A square equals to 56 point something like 9 or something. A square equal to 56 point, depending on your value, 0.7, 0.8, 0.9, you can get any of this. You now find the square root of 56.9 to get h. H is the square root of that number. The square root of h is the square root of 56.9. H is the square root of 56.9. So what do we get? What do we get? 7.54. So we get our height, h equals to 7.54. 7.54 centimeters. Now that you got the height to be 7.54 centimeters, what is it then we do? You have found that all this that we are doing, we were just looking for a way to be able to find the radius and to find the height. Now we found the height and the radius. The next thing for us to do is to find the volume of the cone now. Okay, the next thing for us to do is to find the volume of the cone. Because now we've got it all it takes to find the volume of the cone. So we simply say volume of cone, V cone, volume of cone is equal to 1 over 3, like we stated before in the formula, 1 over 3 pi r squared, right? 1 over 3 pi r squared h. 1 over 3 pi r squared h. So we just substitute everything we need now, we have it. So volume of cone is equals to 1 over 3, we put the values here, 1 over 3 times pi, which is 3.14, or 22 over 7, 3.14, times the radius. We got a value for the radius. The radius was 9.3, so 9.34. We say times 9.34, we square it, right? Because it's r squared. 9.34 square times the height. The height we just found to be 7.54. 7.54. Okay? So we key everything into our calculator, we get the volume. 1 divided by 3 times 3.14 times 9.34 squared times 7.54. Everything will give us 600. If we approximate to the nearest three significant figure, we'll get 688.9. 688.9. Okay, 688.9 centimeter cube. So if we change to three significant figure, we get 689. So we get 6. Volume here will be equivalent to 689. Okay, I hope we understood everything we talked about. That in the exam, they give you a major arc. The question, remember where it came from. They gave us a major arc, and they say this arc was used to make a cone. And they gave us a slant length. This is not the radius, the slant length of the cone. But here, the radius of the cone is unknown, and the height of the cone is unknown. And then they ask us to calculate the volume of this cone. I said you cannot do the volume of this cone unless, first of all, you use this length, you use this arc length to form the base circular part of the cone. So this arc length is same as the base circular part of the cone. Okay? The sector below is able to form a cone as shown. Find the volume of the cone. That's the question, as easy as that. So it's your prerogative, it's your discretion to figure out what you need to do first and what you need to put together. So we started by saying that this arc length is same as the circular part of the cone. So we calculate the arc length, and when we are calculating the arc length, this slant height is same as this radius of this circle. So we key that value here, and we'll be able to get the arc length. That arc length is the circumference here. Is the circumference. So after we got it the circumference, then we can use the value from the circumference to get the radius of the cone. Once we do that, we solve one parameter. After we get the radius from making the arrow subject here, we got it one parameter. Then once we get the radius and we know the slant height, we can find the real height of the cone by using Pythagoras theory. Once we calculate the real height, then we can calculate the volume. Once you know the radius and the real height, you can calculate the volume of the cone. So that's all we have done. It's not like we did magic, we didn't do any magic. Okay, now let's see another question. Okay, this one is going to be your question. Okay, let's see how we figure it out. Since we already got a hang of it, right? Right? The question says two cones, A and B, shown below, have the same volume. So the volume is same. So what will we do? If they give us one, we can find the volume of that one and use that same volume for the other one that is not given. We say two cones, A and B, shown below, have the same volume. Using the dimension shown and given that the base of the circumference of the cone B is 600. The base of the circumference of this one is 600, right? Of B, this B, right? So of B, cone B, this B. This B and this is A. Okay? So given the dimension, is it that the base circumference of the cone B is 60 centimeters. Calculate the height H. The height H, okay, centimeters. So we should calculate the height H. So they want us to calculate this H, right? And the base, so we have to find the radius. We have to find the radius, right? We have to find the radius first. How do we find the radius? By using circumference formula. Okay? By using circumference formula. So let's find the radius. Say C is equal to 2 pi r. Equal to 2 pi r. Remember they say the base circumference of B is 60, right? Is 60 centimeters. So we're going to say 60 is equal to 2, or 60 divided by 2 pi. 60 divided by 2 pi equal to r. Okay, equal to r. So r will be what in this regard? R will equal to what? 60 divided by 2 pi. So 60 divided by 2 pi. 2 pi is 6.28. 60 divided by, you get 9.55, right? We get 9. Not 60 divided by pi. 9.55. So these are radius. We've got the radius 9 of this one. 9.55. Okay. we can find the height by first of all calculating the volume of this cone. You know, when we know the volume of A, VA, volume of cone A is equal to the volume of B, of cone B. The volume of A is equal to the volume of B, right? The volume of A equal to the volume of B. So once we get the volume, we know the figure, we slot it to the volume formula of this one, we make H the subject. Now, once we know the volume, we will substitute. You know that volume formula, V equals to 1 over 3, 1 over 3, pi r square, H. Once we get the volume from A, when we are using it for VB, we call it, okay, when we are doing VB, we will make H the subject. We make H the subject, but that's the another phase, because they want us to calculate this H. But to do this H, you must know the volume. If you don't know the volume, you cannot. And you cannot use this one that you're looking for to find the volume. You cannot use this one that we're looking for to find the volume. You have to use this one to find the volume. So we're going to use this one now to find the volume. And that volume we get with VA. And we say that VA equal to the VB. And then we use VB to find H by making H the subject. Because we've already got the radius of this one. We've got the radius. So this one is, everything is almost set. Just for us to get VA, which is equal to VB. And we bring the value here. And in order to make H the subject, and then we get the height that we're looking for. So let's find VA. So we say VA, the volume of cone A, is equal to 1 over 3 pi r square H. Now this radius is not the radius we looked for just now. It's the radius of cone A, which is 5. And the height we're using is the height of cone A, which is 15. So that's why I say VA, so that we can differentiate cone A and that of cone B. So VA, that's volume of cone A. When I write VA, I'm saying the volume of cone A. VA is equal to 1 over 3 times pi, which is 3.14, times the radius, which is 5, times 5 square. 5 square is 25, times 5 square, then times the height, which is 15, times the height, which is 15. So that gives us what? What is our volume? 392.75, right? So our VA is equal to 392.75 centimeter cube. Okay, so that's our VA, centimeter cube. Okay, so these are VA. Remember, they said the two cones have the same volume. So the two cones A and B shown below have the same volume. So this terminology helps us to simplify the problem. See, by saying that they have the same volume, cone A and cone B, they have the same volume. So that simplifies our problem. So I will take this value I have got it for cone A as also the volume of cone B, because the question says they have the same volume. Since they have the same volume, I'll take the volume of cone A I just calculated, because cone A has all the parameters to be able to calculate the volume. So since they have the same volume, I'll take the volume I just calculated for cone A and use it as a cone B, as the volume of cone B. So we come here, we're going to take the V, we say VA equal to VB, remember that, the volume, because they have the same volume. So the volume of cone A is also same as the volume of cone B. It's also same as the volume of cone B. Okay, so if that is so, then we take the value. So we write VB is equal to, remember the question is just asking us to calculate height. But you cannot just get the height if you don't do all these things that we're talking about. You cannot calculate the height if you don't do all this one. Remember, we calculate the radius of this. We calculated the radius from this circumference. How do we get it? Because they gave us this circumference to be 60. So we use that as a circumference formula. C equals to 2 pi r. We make r the subject, and we're able to get the radius of this one. So it is that radius of this one that we're going to put into, slot into this formula. Okay? It is that radius we're going to slot, not the radius we use for cone A, that we're going to slot into this formula. So here we're going to make the h the subject, because that's what they asked us to find, the height of the cone B, the height. So we say VB, which is the same value, 392.75. So we slotted that same value, 3.92.75 times is equal to, is equal to, we can change the color in order to show we are doing a different one right now. Is equal to 1 all over 3, is equal to 1 all over 3 times pi, which is 3.14, times pi, which is 3.14, times, what's the radius? 9.55, right? So times 9.55 squared. Don't forget to square. If you forget to square, you fail it. 9.55 squared. Or if you don't know, you just say 9.55 times 9.55. There times h. Remember, we're looking for h in this regard. We're looking for h. So first thing, you cross multiply. You go to multiply this value with 3. See this value? You go to multiply with 3. So 392.75 times 3, what do we get? We're going to get 1,000 something. Okay, so we get 1175, right? 1178. We get 1178. If you multiply, you know why we multiply by 3? I'm cross multiplying. I'm cross multiplying. The denominator on the right with the numerator on the left. Okay, 0.25. We get 1178.25 is equal to, now we multiply the values on the right. 3.14 times 9.55 times another 9.55. What do we get? We get 286, right? So here we get 286 point what? 0.56. 286.56 approximately. 0.56 h. Okay, you write the h. H is going to be the subject. So to find h now, you're going to make it the subject. H will be equal to, you divide both sides by, let's take a different color, probably a red one or orange. Divide here by that same value, 286.56, 286.56. Same here, divide both sides by that same number, 286.56, 286.56. So this one, the numerator will cancel the denominator. So h will remain. That's the h I wrote here. Then divide this by this. What do you get? 1178.25 divided by 286.56. We get 4.1, which is approximately 4.1 centimeter, 4.11 centimeter, okay, which is approximately 4. So our height is equal to 4 centimeter of B, equal to 4 centimeter. So meaning B was not so tall. B was not so tall, but the cone A was very tall with a height of about, okay, we didn't calculate the height of A anyway. Wait, there's something we didn't do. Okay, so for this question, because they gave us this height as 15, it's okay. For this question, they gave us this height as 15, the real height. But if here is 15, another question they can make here 15, the slant height. You cannot use the slant height. For example, if this question was like this, cone A was like this. Okay, that's all for this question. We solved according to what the question gave us, right? So we solve according to what we have in the question. But if the question was like this, cone A, for example, if cone A here was 15, if here was 15 centimeter, you cannot use 50 to find the volume. We just went straight to find the volume. Okay, you cannot use 15 to find the volume. And here was the 5. And here was 5 centimeter for the radius. Okay, if cone A was like this, then we need to do something. You understand? If cone A was like this, because in the exam they might bring it, but it will look like this one. If cone A was like this, cone A, we just went straight to find the volume. Why? Because they gave this height was 15. But if 15 is a slant height, we cannot use this straight to find the volume. So in this case, we must find what? We must find the height, h. We must find h first. We must find h first. So in that case, you have to use Pythagoras theory to find h. Please pay attention. This is very, very important. Okay, pause the video and learn something here. This is h, and this is 5. If cone A was structured like this, the answer would have been different. So here we would have found the height h first. So, and how to find height h is to say if the longest side h squared is equal to the longest side square, which is 15, minus 15 square minus 5 square. Pythagoras, okay, minus 5 square. 15 square is 225. So here you have 225. You have 225 minus 25. That will be 200, right? So we find the square root of 200. So this will be h squared. So to find h, find the square root of 200. H equals to 200. What's the square root of 200? 40.14, right? So to find the square root of 200. So h would have been 14.14. So we would have used 14.14 to calculate the volume. Okay, or 14, approximately 14 to calculate the volume. Okay, we would have used 14 because the height is 14 to calculate the volume. If the question was like this. Okay, I just wanted to establish that in case you see the exam, this one that was given, the 15 or whatever value was here. And then you say, oh, we didn't study like that. We didn't study like that. So if they give you this and you have the radius, you use Pythagoras theory to find the real height before you calculate the volume of VA, which will now be equal to VB, and then you move on as we've done before. So that's for that. The last part of this one is the surface area of the cone. Okay, the surface area of the cone. So let's take a look at the surface area of a cone. I think after that we'll be done with the cone. I will be done with mensuration, 3D shape mensuration. Surface of the cone. Okay. The surface area of the cone comprises of the area of the circular part, right? See the area of the circular part. It comprises the area. When we say surface area, I didn't write the area, sorry. Surface area of a cone. Surface area of the cone. So it comprises the area of the circular part. You have to calculate the area of the circular part and the area of the curved body. So the surface comprises the area of the circular part, and so it comprises of the area of the circular base and the area of the curved face and the area of the curved body. This curved face, this one. It's not really a triangle. It's actually a curved, cone. You must have played the cone game before. So it comprises of the area of the circular part and the area of the curved body or curved face. Now the area of the curved face is equal to the area of the sector from which it is formed. So this one is always equal to the area of the sector from which it is formed. So if you want to calculate the total surface area of a cone, so we go to calculate the area of which is pi r square, area of the circular base, and the area of the sector from which we formed this. We calculate the area of the sector. So two things you need to remember. It's area of circular part and area of the sector from which we formed the cone from. Is that okay? So that's what it is. So area of the base area is pi r square. The base area is always pi r square. So the base area of this one is pi r square. So base area is pi r square plus the area of a sector and area of sector from which we form it is usually theta over 360, right? Over 360 times pi r square, right? Times pi r square. Times pi r square. So if you look at this, we have pi r square, we have pi r square. We can factorize it out. We can factorize it, right? We can factorize the pi r square out. We now have 1 plus theta over 360, right? 1 plus theta. So we can have pi r square into 1 plus theta over 360. Plus theta over 360. So we can have this as our total surface area of a cone. So, but sometimes it depends on the way the question is structured, what is being asked, that we know exactly what we have to do. Okay. Now, what if we have a question like this one? What if we have a question like this? We have space on any side. Okay, I think we only have to manage here. The space is finished. Okay, so we have, the shape we drew at the beginning. Let's go back to that question. This one. Okay, but the sector is kind of different. But the triangle is same. Kind of a little bit different. What if we have them like this? Because we don't have enough space to redraw. What if we have a cone like this? We have a cone like this. Okay, here the radius is 5. the radius is 5. So arrow is 5. Here is 5. 5 centimeter. And the slant height is 12 centimeter. And then we have a sector that was used to make this cone that looks like this. And this is the angle of the sector, phi. And here is also 12. Of course, we've already learned that this one for sector is always equal to this one. And why this is the circumference of the base, right? So here is 10 pi. 10 pi. Which is 31.4. 10 pi is 31.4. So this arc length is always equal to this circular whatever. Okay, the arc length, this arc length is equal to this circular part. And this one is always same as this. Okay, so here is a calculate the total surface area of the cone shown on the left. The total surface area of this cone, this one. So the first one is to calculate the circular part, right? So they say we should calculate the total surface area of this cone, this cone. So the first thing we do is to find the area of this base circular part, which is pi r square. You know, pi r square. So we say pi r square. And this will be what? Pi times 5 squared. 5 squared is 25, right? 5 squared times pi, which is 25 pi. So we get the circular part to be 25 pi. If you can leave your answer in terms of pi. Okay, 25 pi. Then in the end you convert everything to centimeter square. So this is the base area, this area. Now we have to find the area of the sector that was used to make this. But the problem here, we don't have the angle of the sector. We don't have the angle of the sector. So probably we can use the arc length formula to find the angle. We can use the arc length formula to find the angle. So we say the curved surface area can best be visualized if drawn as a sector, right? As shown in this diagram. If we draw it as a sector, then we can visualize the curved surface. We need the area of this. To find the area of this, we have to find this angle. And to find this angle, we know the arc length. This arc length is equal to this circular part. So we use that concept to calculate the angle. And once we get the angle, then we can calculate the area of this sector. Okay, we can calculate the area of this sector. So, and once we calculate the area of this sector, which is the area of this curved body, we add it to the area of the circle, and we get the total surface area. Okay, so that's the radius of the sector is equivalent to the slant height. We already established that. The radius of this sector is always the slant height of the cone, right? Now, the curved perimeter of the sector is equivalent to the base circumference of the cone. The curved perimeter of this sector, this one, the curve, the arc length, the curved perimeter is always the base circumference of the cone. It's always equal to the base circumference of the cone. So we can say theta or phi, this angle, over 360 let's find the arc length, right? right? 5 over 360. Okay, you can also say 5 over 360 is same as what? It's same as, remember this one, the arc length? The arc length, which is equal to the area of this. You remember this? This arc length was equal to the base circumference. The base circumference, not area, base circumference. So this arc length is always used to make the base circumference. So we can say equal to 10 phi over the base circumference. What was the base circumference? 25 pi, right? Over 25 pi. Such that this pi will cancel this pi, right? This pi will cancel this pi. We have 10 over 25. So we can cross multiply and find the phi, this pi. This is actually phi. So if you cross multiply, you have 25 phi times 3,600. So you divide 3,600 by 25. You get your angle phi to be 150 degrees. You know, all we do is to find the angle. Another way you can find the angle, you may not just follow this shortcut. Another way is to use the arc length. You say theta or phi over 360 times 2 pi r, right? 2 pi r. Okay, this one is 24, not 25. 2 pi r. See, maybe I'm making it clumsy for you guys. We say, see, this one, let me do it out. We say this arc length is always equal to the base circumference. Are we there? The arc length is equal to base circumference. Do we get that? The arc length is equal to base circumference. We say arc length equals to the circumference. The arc length of the sector is equal to the circumference of the cone. Okay? So we already established this. If that is true, now let's calculate the arc length, calculate the angle from this arc length. Okay? Let's calculate the angle from this arc length. So we say arc length is the phi over 360. I actually wanted the shortcut, but I can feel it that it will make you froze. So you say phi over 360 times 2 pi r. 2 pi r. So 2 pi, and I'll put the radius. Radius in this sector for sector is 12. So times 12. Times 12. So I will have 24 pi, right? I have 24. And this arc length is equal to what? The circumference. And the circumference we've calculated to be 25 pi. So I put 25 pi here. I put 25 pi here. Do you understand? Why do I put 25 to replace the arc length? Because it's equivalent to the circumference. The circumference was 25 pi. We look at it when we did it here. The circumference was 25 pi. Sorry. Let's do the circumference. What was the circumference here? 2 pi r, right? 2 pi r. So 2 times r is 5, 10. Okay, we got 10. That's when we get 10 pi. Sorry. They told us it's 10 already, even if we didn't calculate it. But if you calculate it, it's still 10. So it's 10 pi. Okay? This 10 pi is same as this one. So I put 10 pi here, not 25 pi. 25 was for area, when we did for area. So here is 10 pi. So 10 pi is equals to 5 over 3. So if you evaluate, you have what? Here 24 pi. So you have 10 pi. If you evaluate, you have 10 pi is equal to 24 Why 24? 2 times 12 here. 2 times 12 times pi, you get 24 pi. You get 24 pi. Phi. I'm only multiplying everything on the numerator, everything on top. Divide by 360. So if I cross multiply, divide by 360. If I cross multiply, I have 360 times 10 pi. We have 360 times 10 pi. 360 times 10 pi. We're just looking for I already got the angle, but I'm just showing how. Because I follow the short way. 360 times 10 pi is equal to 24 pi phi. Is equal to 24 pi 5. So if you make phi the subject, you have all this one divided by 24 pi. You have 360 times 10 pi divided by 24 pi. So if you make pi the subject, the angle which we are looking for, this angle will be 360 times 10 pi, 360 times 10 pi all over 24 pi, all over 24 pi, all over 24 pi. So tell me what you got. You get 150. Yes, that's how I got this 150. I'm only showing you. We'll get there 150 degree for the angle. So we get the angle 150 degree. So once you get the angle 150 degree, then you can calculate the area of the sector. Area of this sector, which is represent the area of the curved body of the cone. So area of the sector, I know you people will say, oh, so we've not even got the area. No, we've not got the area. So once you do that, you have area of the sector. Area sector will be equal to this your 150 degree that you got, divided by 360. 150 degree you got, the angle you got, divided by 360, multiply by 2 pi r, multiply by pi r squared. Remember, we're looking for the area. Now, what's the arrow now we're going to use? What's the radius we're going to use? What is the radius we're going to use? 12, right? We're going to look at it. We're using 12. We're using 12. Multiply by 12 squared. So times 12 squared. 12 squared is 144. That's 12 times 12. Then multiply by pi, multiply by key all this one and tell me what you got for the area of the sector. What do you get for the area of the sector? Okay, 188.5. So we got 188.5. That's the area of the sector, right? Or you say 60 pi. 188.5 or 60 pi. If you want to leave the answer in terms of pi, okay, you get 60 pi. So now total surface area, you know the total surface area is the area of this base, of this circular part, which is 25 pi, the one we got at the beginning, this one, 25 pi, plus the area of the curved body. We say the curved body is the same as a sector. Now we calculated the area of the sector. So we just say 25 pi plus 60 pi. Okay, this 188.5 is same as 60 pi. So total surface area, we don't have space. We are managing anywhere we see space. Okay, the TSA means total surface area. The total surface area is equals to the 60 pi, which is 188.5, 60 pi, plus the area of the circular base, which is 25 pi, which is 25 pi, which is 25 pi. So we get 85 pi. you get altogether 85 pi. So you just press in your calculator 85 times 3.14. You get your final answer. If you want to put your answer in, which is 267 to 3 significant figure. Okay, which is 267 centimeter. 267 centimeters square. 267 centimeters square as the total surface area of the cone. So, frankly speaking, it's not a difficult thing. The total surface area of the cone, just all you need to know about cone is that you can calculate the area of the circular part. Well, that's one. The second one, the area of this body is the sector. So, you use this, whatever is given here, to be the radius and find an angle for it. See, you form a sector, and whatever you get as the circumference here is the arc length. This is the only thing you need to remember. The circumference of the cone is the arc length of the sector. Whatever you calculate as the circumference here is the arc length. Once you get the arc length, okay, once you know the circumference, you get the arc length. So you use the length of an arc to find this angle, because you already know the circumference. You equate it and find the angle. Once you get the angle, you get the area of the sector. Once you get the area of the sector, you add it to the area of this base, area of pi r square here, and then you get the total surface area. Okay, so with this we come to the end of our today's class. Thank you for joining us.